Good evening to sir and Assalamualaikum to my beloved friend. In this video, we want to present our PHY150 video presentation. The topic for our video presentation is renewable energy source, more specific is hydroelectric. But before that, I want to introduce myself and my beloved friend. My name is Abang Muhammad Aidil bin Abang Muhammad Pusrah. Second member is Wahida binti Si Hussein. Third member is Nur Nashahira binti Muhammad Faizal Tian. Fourth member is Alias Sulan anak Joseph Bruka, and the last member is Nur Ain Shamimi binti Zul Hari.
First, what is renewable energy? Renewable energy is the energy that derives from sources that naturally replenish on human timescale. The sources is including sunlight, wind, and wave. Next part is for reliable electricity and magnetism concept of renewable energy. The first one is electromagnetic induction. Electromagnetic induction is the process where a changing magnetic field induces an electric current in a conductor. The second one is transformer technology. Transformer technology plays a vital role in renewable energy by stepping up and stepping down the voltage for efficient transmission and distribution. The last one is generator principle. Generator principle is the process that relies on the interaction between magnetic field and conductor to generate electricity.
Now, let's go for a deep exploration about hydroelectric. Hydroelectric power harnesses the energy of flowing water to generate electricity. The components that are needed in a hydroelectric power system are dam via reservoir. In the reservoir, large amount of water can be stored, and the rate and consistency of electricity are determined by the controlled discharge of water. Next, turbine. Turbine is an essential element in the process of converting the kinetic energy of the flowing water into mechanical energy. Types of turbine that we have are Francis, Kaplan, and Pelton. The third component is generator. Generator is connected to the turbine. It uses the principle of electromagnetic induction to transform mechanical energy into electrical energy. So what happened in the process of hydroelectric is that first, water is gradually released under control from the reservoir, harnessing the kinetic energy. So when the water flows, it strikes a turbine's blade, causing it to rotate and transferring kinetic energy to mechanical energy. As we all know, turbine is linked to the generator. As the turbine rotates, an electric current is induced in the coils of wire by their interaction with the magnetic field inside the generator. The generated electrical energy is represented by this induced current. Then, power lines are then used to provide this electrical energy to residences, businesses, and other consumers.
Example of real-world implementation, the utilization of turbine in dam to transform the energy of flowing water into electricity is practical use of hydroelectric power generation. For example, the Bakun Dam was built to supply the increasing need for electricity. Nonetheless, Peninsula Malaysia is thought to have the majority of this demand rather than East Malaysia, where the dam is situated. When finished, it will produce 2,400 megawatt of power.
So now let's move to the benefits of hydroelectric. First of all, it is renewable and clean energy because it harnesses the power of flowing water to create electricity. Furthermore, it does not produce greenhouse gases or air pollutants. Secondly, it is reliable and consistent power because it does not depend on environmental factors like solar or wind electricity. And during peak demand periods, energy can be produced from the water held in reservoirs behind dams. The third one, water storage. The reservoirs created by hydroelectric dams can provide water storage capacity for agricultural irrigation, industrial use, or urban water supply. This makes them a valuable resource for communities in arid or semi-arid regions. So the next one is the challenges of hydroelectric. First one, it have environmental impact. The construction of hydroelectric dams can have significant environmental impact, including the displacement of wildlife and fish population, changes in water temperature and flow patterns, and the loss of natural habitats. The second one, the maintenance cost. The maintenance cost of hydroelectric power plants can be high due to the need for regular inspections and repair of the dam structure and equipment. This can add to the overall cost of hydroelectric power generation over time. The third one, the dependence on water availability. Hydroelectric power generation is dependent on the water availability, which can be affected by drought or changes in precipitation patterns due to the climate change. This makes hydroelectric power generation less reliable in some regions where water availability is limited.
So, what is the future developments and innovation of hydroelectric? So, the first one is advanced turbine technology. By installing advanced turbine technology, we can increase efficiency and reduce environmental impact. This innovation may include the development of fish-friendly turbines, modular turbines, and design that can harness energy from low-head and small-scale hydro installation. The second one is material and design. Flexible material and adaptive structure can help ensure the resilience and adaptability of hydroelectric installation. Traditional hydroelectric turbines can pose challenges to aquatic life, particularly fish. By developing fish-friendly turbine design, we can reduce the risk of injury and mortality for fish passing through the turbines. So the third one is floating hydroelectric platform. Floating hydroelectric platforms are a type of technology designed to generate electricity from water bodies without the need for traditional dams or fixed structure. These platforms are typically installed on the surface of bodies of water such as lakes, rivers, or even offshore locations. And the last one, pump storage hydroelectricity. It can act as a large-scale energy storage system. For example, during periods of low electricity demand or when renewable sources produce excess electricity, surplus energy is used to pump water uphill, storing potential energy. This stored energy can be released rapidly when demand is high, providing a rapid response to fluctuation in electricity demand and contributing to grid stability.
For the conclusion is the sustainable potential of using water resources has been illuminated by our investigation into hydroelectric and renewable energy. Indeed, the power of water can help us traverse the problem of climate change and move toward a more resilient and sustainable energy future. That's all from us. Thank you and hope you enjoy our video, sir.